Okay, Year 11, let's take a look at the questions on your systems architecture test. We'll start, logically, at question 1. Question 1 was answered well by a lot of students. The question asked you two types of operation carried out by the ALU. And as long as you remembered what ALU stands for, you usually got the marks here. ALU stands for Arithmetic Logic Unit. So the two types of operation are arithmetic operations and logic operations. Here you just had to list those two, so it was quite a straightforward question. If you need to give examples, arithmetic operations are operations such as adding numbers together. Logic operations are operations where a comparison is done, for example, seeing if two values are equal or if one value is greater than another, for example. Question 2 asks you to explain the steps involved in the fetch, decode, execute cycle. Some of you attempted to make this question more complicated than it needs to be. Remember that you do not need to know what happens to the different registers at each stage of the fetch, decode, execute cycle. That comes at A-level. I put that in your lessons because it's quite hard to remember what the registers do if you haven't at least looked at that idea of what's happening to the registers during the cycle, but you would not be asked to specify what's happening to the registers during the fetch, decode, execute cycle in a GCSE paper. All that's needed here is a 4-mark question, and actually I would allocate 1 mark to each word out of fetch, decode, execute and cycle. Many of your answers were strong here and indicated that you had a good idea of what happens during the cycle, but you weren't always specific enough, or sometimes you didn't use the correct terminology. I'm going to show you a picture which helps me to explain what's required here. This picture is taken from Teach ICT, by the way, which is an excellent website if you need to look anything up when you're revising. So we can see from this diagram that in the fetch stage, an instruction is fetched from RAM, from main memory. That would give you 1 mark, but you need to specify that it's an instruction or a piece of data that is being fetched, and it needs to be those words instruction or data, because information is not anything that a computer deals with. Data only becomes information when human beings attach meaning to it, and the exam boards are really hot on that. So you need to be really clear about using the terms instructions and data, and pretty much never write the word information in a computer science exam. It's not good enough just to say fetch the data or instruction, however. You have to specify that it's being fetched from main memory or from RAM. And a lot of you lost the mark because you weren't clear enough on that. So 1 mark for saying that an instruction is fetched from RAM. The second part is actually delightfully simple. The instruction is decoded. But again, you must say instruction. You cannot say decoded for data. The only thing that you can use data for is in the fetch part of the cycle, because remember, when we fetch from main memory, it could be an instruction, such as add, or it could be a piece of data, such as the number that is to be added. But only the instructions would be decoded, because decoding is where the control unit looks at the instruction in the computer's instruction set and works out what it's actually supposed to do with it. So, to recap, 1 mark for saying that an instruction or a piece of data is fetched from RAM. 1 mark for saying that an instruction is decoded. 1 mark for saying that an instruction is executed. Again, that must be instruction is executed. And 1 mark for explaining that because it's a cycle, that the whole thing will repeat again at the end. After the execution, then the next instruction would be fetched and so on. So 1 mark for showing your awareness that it's a cycle. So not too complicated a question when you know what it's asking, but you do have to be really careful about the terminology there. There was also a markup for grabs if you showed a little bit more awareness than you need. For example, if you explained that the program counter is incremented each go around the cycle, because remember the program counter is the register that points to the next instruction to be executed. So every time we go around the cycle, that has to be incremented. Unfortunately, a couple of you lost marks because although you remembered that idea, you didn't remember the word incremented. Somebody said iterated. Remember, iteration is using a loop in a program, so it's not what we're talking about here. And somebody else used another word beginning with I, which I can't remember off the top of my head, but you need to make sure that you get the terminology right if you're going to say it. So the program counter is incremented. Question 3, the purpose of the memory address register and the memory data register. Really, the most straightforward way to get the marks on what the registers in the processor do is just to learn the wording off by heart. Unless you've got a really secure understanding of the fetch, decode, execute cycle and you can really delve into your understanding of it, the easiest way is just to learn it off by heart. So the answers are that the memory address register holds the address of the instruction or data that's currently being used, and the memory data register stores the actual instruction or the data that is currently being used. Some of you didn't specify currently being used, and some of you gave answers that indicated that maybe more than one piece of data or more than one instruction could be stored there. It needs to be really clear that it's one instruction or one piece of data at a time, and it's the one that's currently being used. That's reminded me of another thing that some people, I gave benefit of doubt on question 2 as well. You need to make it clear one instruction is being fetched at a time, one instruction is being decoded at a time, one instruction is being executed at a time, and then the process begins again with the next instruction. Some of you said general things like, oh, the instructions are fetched during the fetch stage of the cycle. Well, you need to be really clear that you're showing the examiner that you know that it's one instruction at a time, so be really careful with your wording there. On to question 4. Explain how the following can affect the performance of a CPU. When you get questions like this, you need to explain first of all what the factor is, and then second of all how it will affect the performance. And some of you missed out one part of that or another. So some of you were able to correctly tell me, for example, that the higher the clock speed, the faster the CPU will perform, and you got 1 mark for that, but you weren't able to tell me why. You weren't able to tell me what the clock speed actually is. The clock speed is the number of cycles that the CPU can carry out per second. If you remember that, then you can explain in full to get your 2 marks. The clock speed is the number of cycles that the CPU can carry out per second, or you could say the number of instructions that the CPU can execute per second. 1 mark. The second mark for then explaining that therefore the higher the clock speed, the better the performance of the CPU. We follow that same structure for the next part of the question, which asks you to explain number of cores. For some reason it's showing as A, again here of course it's B. The number of cores, you could say, affects how many instructions can be executed simultaneously or at the same time. That would be 1 mark. Then you would say that therefore the higher the number of cores, the better the performance of the CPU. When you're talking about the number of cores, it's really important to show your understanding that it affects the amount of instructions that can be carried out at the same time. Some of you said vague things like, oh, the more cores there are, the more the work can be divided up. But you're not showing your clear understanding that the tasks could be carried out at the same time. So make sure that's really, really clear in your answers. 2 marks for the description of what is meant by an embedded system. Sorry, I'm just checking that my screen recorder is still going because I've lost my little timer in the corner.